Tonight's homework lesson is Unit 6, Lesson 9. These are quite hard for the students, so a picture is really a powerful tool when we're doing these. So the first one says, Carl is making a rectangular dog run. So I'm going to make a rectangle. He has 36 one-yard sections of fence that he plans to use to keep his dog inside. He wants the run to be as long as possible. What is the longest whole number length he can use for the run? So I need to find my side length. He wants this to be the longest length that it can be. These are my adjacent sides. This is what we've been working with. As you can see, this is half of a rectangle. So I'm going to take half of 36. So if I take 36 and I divide it by 2, I'm going to get 18. How are the children going to do that? We haven't really had it. So I would say do 2 circles and then do tallies 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on until you get up to 36. Then count the tallies in one of those, and that should give you your 18. So that's a strategy that the kids could use. So now I have to see what 2 digits or numbers can I add up to give me half. Well, I can use 10 plus 8. I can use 11 plus 7. I can use 12 plus 6. I can do 13 plus 7. No, 13 plus 5. 13 plus 5. I think that's it. 10 plus 8, 11 plus 7. Well, I can use 9 plus 9, but if you notice, 9 plus 9 is more of a square than a rectangle. He wants it long, so I'm already going to just say that one isn't going to be one, because one side is going to be the same as the other side. So if I look at these, the longest one that I can have, I can still go higher, can't I? So 13, I can do 14 plus 4. I can do 15 plus 3. I can do 16 plus 4. No, 16 plus 2. I can do 17 plus 1. There, now I can't go any farther. And if I look at all of these, I have a side of 10, 11, 12, 13, 14, 15, 16. 17 would be my longest side. So this would be 17, and this would be 1. So it says, what is the longest whole number length he can use for the run? So I'm finding my side length. It would be a length of 17 yards. 17 yards. So if I add 17 plus 17, I get 34, 35, 36. That's tough. Let's look at number 2. Bob has 37 tiles with dimension of 1 foot by 1 foot. This right here confuses the children. They want to put it in their equation. He wants to tile a closet that is 7 feet long and 5 feet wide. So I'm going to draw my rectangle. This is 7 feet. This is 5 feet. He has 37 tiles. Does he have enough tiles? If so, how many tiles will be left over? So I need to find my area. When I'm working with putting tiles down in the inside, that's my area, because my my answer is labeled in squares. So I take my side length, 5 times 7, equals my area. 5 times 7 equals 35. Area equals 35 squares. Don't forget to put the squares on there. And I box that answer. So that's how many tiles he needs for a closet that's 5 feet by 7 feet. He has 37 tiles. Does he have enough tiles? Yes. Does he have some left over? Well, he had 37. He used 35, so he has 2 tiles left over. So N equals 2 tiles. So for that one, I have 3 answers. I find my area. I answer yes that he has enough tiles, and then I have to find out how many tiles he has left over. Number 3, a stage is 10 yards long and 5 yards wide. So it's 10 yards long and 5 yards wide. Here's my stage. The orchestra pit is in front of the stage, is 4 yards long and 2 yards wide. So I'm going to have 4 yards long and 2 yards wide. So this is going to be a 4. This is going to be a 2. So here's my stage. Right in front of the stage is my orchestra pit. It's 2 by 4. My stage is 5 by 10, 5 feet by 10 feet, or yards it is, 5 yards by 10 yards, 2 yards by 4 yards. It says, how much floor space do the stage and the orchestra pit take up? So I got 2 of them. I got 2 rectangles here that I have to find the inside. How much space does that use up? So I'm going to find my area. So my area equals 5 times 10, because when I find area, I multiply my adjacent sides. Now I have the small one in front, so I have to put this in parentheses and add to that my pit in the front, which is 2 times 4, and that will equal my area. So 5 times 10 we know is 50, plus 2 times 4 is 8. So if I add 50 plus 8, my area equals 58 squares. I box my answer. Okay. Number 4. Tracy embroidered 26 quilt blocks with letters and 10 quilt blocks with numbers. She wants her quilt. Now look at this, she only has 1 quilt. She's not going to make a quilt with the letter blocks, and she's not going to make a quilt with the number blocks. She needs to put those together to make 1 quilt. So we can do that first. So we have 26 with letters and 10 with numbers. She wants her quilt to have 6 rows. So I'm going to divide it by 6 for my 6 rows. How many quilt blocks will be in each row? Equals N. I'm not finding my area. I'm finding how many quilt blocks will be in 1 row. So I take my 10 and my 26 and I add them together and I get 36. I'm going to divide those 36 into 6 rows. 36 divided by 6 is 6. So N equals 6 quilt squares. And I box my answer. I didn't do anything. I'm not finding the perimeter. I'm finding an area, but I'm finding the area of a small part of it. So I almost have doing both of these here. It's kind of a tricky one. Okay, I hope that helps, because this is really, really hard for them. And that's the end of tonight's lesson, Unit 6, Lesson 9.